Alright, today we're going to advance our skills in solving systems of equations with elimination just a little bit. So if we're going to use elimination to solve this system of equations, the first thing, there's my cell phone, the first thing that we're going to have to deal with is remembering what elimination does. In elimination, I add two equations together, and when I add them together, I want one of the variables to add up to 0 so that that variable gets eliminated from the system. Unfortunately, the system I have here, if I add these things up, 4x plus 12x doesn't give us 0x, and negative 5y plus 6y doesn't give us 0y. So what I'm going to do here is I'm going to create an equivalent equation using multiplication that will have coefficients that are going to add up to 0. So here's what I mean. If I look at this equation, or this system of equations, I can notice that 4 is a factor of 12. So if I were to multiply this 4x times negative 3, I would have negative 12x. And that negative 12x would be able to add up with that 12x to 0, so that would eliminate the x's from my system. So what I'm going to do is I'm going to choose to multiply this first equation by negative 3. Students will oftentimes ask, well, where did you get that negative 3 from? And the answer is I chose it, and I chose it strategically. I chose negative 3 because looking at the numbers, there was nothing nice that I was going to be able to multiply the negative 5 by to get it to match with the 6. But by multiplying this first equation by negative 3, I recognized that it would give me a negative 12x, which would add with my positive 12x to give me 0 x's. So I multiply the first side of that equation, the left-hand side of that equation, by negative 3. I'll also multiply the right-hand side of that equation by negative 3. And now this new equation that I have, which we know is going to be equivalent because I'm multiplying by the same thing on both sides, but this new equation is going to be negative 12x plus 15y is equal to negative 6. Now, when I bring down the other equation, 12x plus 6y is equal to 48. Now if we look at the two equations that I have, they're going to, when I add them together, the x's are going to eliminate. So I'll add these two equations together. Negative 12x plus 12x gives me 0 x's, so I can pretty much just ignore that term. 15y plus 6y gives me 21y. And negative 6 plus 48 is negative 42. Now I can divide both sides by 21. To solve for y, I would find out that, so that should be positive 42. Just kidding. Positive 42, right, because the 48's bigger. Divided by 21 is going to be 2. So y is equal to 2. And now that I know what y is, I can back substitute to find what x is. So I'll take, doesn't matter which equation, I'll take the smallest equation I can because I like small numbers because I'm lazy. So I'll let the y, now I know that y is 2, so I'll let the y become 2. So I've got 4x minus 5 times 2 is equal to 2. So we've got 4x minus 10 is equal to 2. We would add the 10 to both sides. We would have 4x is equal to 12. We would divide both sides by 4. And we would find that x is equal to 3. So the solution to my system is 3, 2. Just to be really clear, the only thing that's new in today's work is this tool of multiplying by a number. I choose this number. The way that you go about trying to figure out what number to choose is you look at the coefficients that you have and you say, okay, well, is there anything I can multiply one of the equations by so that the coefficients will be equal but opposite? So in other words, negative 12x and positive 12x, or a negative 3 and a positive 3, or a negative 9 and a positive 9. I looked and I saw here that I could multiply the 4 by negative 3 to get negative 12, so that's what I did. I multiplied the whole equation by negative 3, being careful to distribute through on both sides. And when I did that, I was able to eliminate the x's, which meant I was down to one variable, which I could solve for, and then substitute back to find the value of x.